So, we have discussed about the high voltage importance of high voltage transmission system and how the high voltage technology is being used in the country and elsewhere. The main importance of the high voltage technology was developed originally mainly to cater the needs and also to transfer the large quantities of electrical energy economically at very high voltages. Today high voltage technology has spread not only from the energy transmission, it encompasses many other areas of engineering and science. Because of this, high voltage technology is of interdisciplinary in nature. The usage of the technology is being done for various industrial purposes and other numerous applications. So, in the industry, the high voltage technology is being used for the electrostatic precipitators, mainly to remove the dust particles, exhaust dust particles, the flue gases emitting from the factories or the thermal stations. The technology is being used in the spray painting and for the powder coating by the electrostatic applications. The high voltage technology is used in medical and also scientific applications, where the power supplies, particularly the high voltage power supplies, are used for the X-ray, the electron microscopes, the nuclear research purposes, etc. And modern day gadgets of electrical and electronic industries are also using the electrical technology. One such example is about the electrical fences which are used to guard the main buildings and designated companies or the government buildings where electric fences are being used. And in ion implantation particularly in semiconductors industry it is used, and we know that the power supplies in the television sets which uses the high voltage technology. This high voltage power supplies are again used in oscilloscopes, the ignition coils for our motorbikes or the automobiles also use the basic high voltage technology. So, several applications of high voltage technology exist. So, very important not only for the transmission and distribution and also for the regular applications. So, it is very important to know and have a basic information about how these high voltages could be generated in the laboratory level and how this high voltage AC or DC could be used for the testing or verification of the equipments which are used in the transmission, distribution or in the above mentioned industrial applications where these have to be properly verified and they have to be monitored, they have to be tested. So, for such applications it is required to generate high DC as well as high AC, and laboratories provide these facilities for the testing aspects. So, we will briefly look into the generation of high voltage DC initially, then we will also look into the generation of high AC voltages and generation of surges in the laboratory, how these are being used, the equipment are being used for the testing of the accessories insulator strings or the other high voltage equipment in the transmission system. So, very important information which has to be known. So, first we will discuss about the simplest way of generating the DC high voltages. Further we will see how the DC high voltages could be used for the generation of high voltage DC. So, DC transmission or a high voltage DC transmission is known that we are employing for our transmission lines and also for underground cables. This is becoming more and more popular in the recent days. Apart from the transmission and distribution, several applications of high voltage DC voltages particularly in industries as discussed, our research, the medical sciences etc. are being done. So, the high voltage DC used for testing high voltage AC cables particularly of long lengths, as these have a very large capacitance and would require very large values of currents in case if they are tested on HVAC voltages. Even though DC tests on AC cables is a convenient and economical, but suffer from the fact that stress distribution within the insulating materials is different from the normal operating conditions. In industry, high voltage DC as mentioned earlier is being used for electrostatic precipitation, particularly in thermal power plants, for electrostatic painting, in cement industry and communication systems. So, high voltage DC is also being used extensively in physics for the study of particle acceleration and in medical equipments. The most efficient method for generating high DC voltages is through the process of rectification, which we have already known, and this simple rectification idea is being used here for further improvement and the generation of higher voltage DCs by using suitable voltage multiplier or voltage doubler circuits depending upon the voltage requirement. So, the electrostatic generators have also been used for generating high DC voltages wherever a suitable generation of these voltages are required. So, now we will discuss the simplest half wave rectifier circuit which is used for the generation of the DC voltages and how this could be used further for the high DC. So, the simplest circuit for generating high DC voltages is the half wave rectifier circuit, which is shown here. This is a single phase rectifier circuit, a single phase, a transformer connecting the output of the transformer is connected to the diode D, it is connected to the capacitor C and the load RL. So, the current flowing through that diode is I of t for a known time and IL is the load current flows through the resistor. So, this is the simplest half wave rectifier where RL is a load resistance and C the capacitance which is used to smoothen the DC output voltage. So, in case if it is assumed or if we assume that the capacitor which is shown here is not connected, then there could be a pulsating DC, there could be a pulsating DC. In case capacitor is absent, there could be a pulsating DC voltage which could be obtained at the output terminals here with the capacitance. So, the pulsation of the output terminals are reduced with the help of this capacitance, that is one point. So, assuming that this transformer which is shown is an ideal transformer and has a very small internal resistance in it, a small internal resistance, and transformer is an ideal and small internal resistance of the diode. This diode, assuming it has a very small internal resistance, particularly during conduction. So, the capacitor C, this capacitor gets charged to the maximum value through the diode. So, the flow of current will be in this way, the capacitor gets charged to a voltage V max during the conduction of the diode. So, assuming that now again if there is no load, that is there is no RL is connected. So, the DC voltage which is seen here across the capacitance terminals, that is between the capacitance terminal here and here, it remains constant at V max, that is it becomes V max here, whereas this supply voltage we have considered at only one cycle. So, if the supply voltage oscillates because of the AC being the positive and negative. So, similarly this during the negative half cycle the plus V max will attain 2 V max. So, this is important. So, because of the oscillation or the supply voltage oscillation, we see the voltage appearing across the capacitor in both positive and negative cycle will be the 2 V max, and this is required for further needed for the cascade circuit to generate a very high DC voltages. So, when the requirement for high DC voltages are to be generated, a voltage doubler or a cascade voltage multiplier circuits are being used for the generation of high voltage DC. The one of the circuit, the important circuit known as the Grenier voltage doubler circuit is shown here. So, the working of this circuit is as follows. Suppose as mentioned earlier, this is a transformer, you have a capacitor C1, you have a diode D1, diode D2, then C2 is again a capacitor and a load. This is a general Grenier voltage doubler circuit. How it functions? Suppose we take the B is a positive, more positive with respect to A, the diode, that is the diode D1 conducts, and hence the terminal M, this terminal M attains a potential of 2 V max. So, because of positive and negative polarity, initially it attains a portion of V max, the terminal B is more positive with respect to terminal A. The diode D1 conducts through the charging and the capacitor C1 to V max with the polarity as shown here, that is a positive polarity. So, V max initially because of the D1. During the next half cycle, the terminal A of the capacitor, this terminal rises to V max and hence the terminal here. So, earlier there is a V max here because of the positive polarity, now due to the negative polarity. So, plus the V max plus the earlier positive polarity V max will rise the potential to 2 V max, and hence the terminal M attains a potential here to 2 V max, and the capacitor C2, this is the capacitor C2, will be charged through this diode D2 to 2 V max. So, that is very important. So, normally the voltage which is seen across the load, this particular load will be slightly lesser than the 2 V max, because this depends, why lies depends upon the time constant of the C2, the capacitance, and the load RL. So, depending upon the load and the C2, there could be a small reduction in the output voltage, could be slightly lesser than the 2V max. So, it depends mainly on the factors C2 and RL. So, further in 1932 Cockcroft and Walton suggested an important improvement over the circuit which was developed earlier, which we discussed by the Greenacher for producing the DC voltages. So, this is the Cockcroft Walton circuit for using for multiple stages or a multiplier circuit. So, where with several diodes and capacitor units are connected to the load, and we could achieve more voltage, that is the intention of generating the higher DC voltages. So, when you closely look the circuit here, various points have been mentioned here. So, during the no load operation, in case there is no operation, load is not connected. So, the portion AB, M and M dash. So, this is AB, M dash and A. So, this loop AB, M dash, M and A, this is the operation which is being exactly identical. When you look this portion, this is exactly identical to the previous circuit, that is a Greenacher voltage doubler circuit, and the voltage across the C1 here becomes 2V max, which we have discussed, and this M will attain the voltage to 2V max. So, during the next half cycle, when B becomes positive with respect to A, the potential of M, this is M, falls, and therefore, potential of N, this N also falls, becoming less than potential M dash. Hence, this C2 is charged through the D2, this diode during the earlier stage. Further, next half cycle A becomes more positive and potential M and this point N rises, thus charging these two capacitors, that is C dash 2 through this diode, that is D dash 2, through this it charges through D dash 2, and finally the capacitors C dash 1, C dash 2 or C dash 3 and C1, C2 and C3 are charged. So, the voltage across here, the column of capacitor consisting of a C1, C2, C3 keeps on oscillating as the voltage alternates, and this column which is oscillating is also known as the oscillating column, which is been known. However, as the voltage across the C1 dash, C2 dash and C3 dash remains constant, and this column is known as the smoothing column in the circuit. Now, the voltages at M dash and N dash, that is M dash this point and N dash, and the output O dash are here, it is 2V max, it is a 4V max and it is 6V max here. So, therefore, the voltage across all the capacitors, that is a terminal here and here, is 2V max except for C1 where it is V max only. For here it is only V max, all other points see a voltage of 2V max. So, the design has to be made in such a way all the capacitors are rated for 2V max except the C1 which is at V max only. So, the total output voltage is 2 into N into X number of stages. So, here it is 3 stages, the N could be any number of stages depending upon the voltage requirement. Thus, use of multi-stage circuit arranged in a manner as shown here will enable to generate a high voltage which is necessary for the applications. So, the equal stress of elements, that is both the capacitors and the diodes used is very helpful, and this promotes a modular design for such generators. during load considering. So, when the load is added to the generator, so the output voltage will never reach 2n into number of that V max. So, 2n is the number of stages. So, V max here again it because of the effect of the capacitance and the RL. So, as the output wave will consist also the ripple of the voltages. So, to reduce the ripple a suitable arrangements have to be done by employing a suitable capacitance in the output side. So, this ripple could be reduced depending upon the requirement of the DC output voltage. So, we have to deal with two quantities, that is the voltage drop and the ripple of the voltages which have been seen. So, whether the ripple quantity have to be reduced, a suitable capacitance could be employed and the ripple could be brought down for the testing aspect. So, these are the basic idea of generating the high voltage DC, and several high voltage DC sets are available across the country. One such example is the DC test setup which has a capability of 2000 kilovolts, current rating of 10 amp, particularly for testing the power cables including a high voltage resistor, automatic grounding system and so on, and this shows the photograph of a high voltage DC set in a laboratory.